right, so in this video we're looking at the orange section, so let's start with number 1. So here it says Matthew invests $10,000 in an account that pays 3% interest. How much will there be in the account after 5 years if the interest is compounded annually, semi-annually, quarterly, and monthly? Okay, so here we have 4 different problems that we're going to have to solve. Okay, so when we deal with annually, well, first off, this is where we're going to use that formula where the amount is your principal, then we have 1 plus r over n, then your exponent's n times t. Okay, so that is our compound interest formula. So for annually, n would equal 1. For semi-annually, n would equal 2. For quarterly, n would equal 4. And monthly, n would equal 12. So we're going to do this problem 4 different times so we can see how his amount would be different depending on how many times it's compounded. All right, so let's start with annually. So again, to find that value, we would find the amount. It would be your principal, which is $10,000, times 1 plus our rate. Please make sure that we change that to a decimal. So your rate divided by n would be 1. And then we'd have 1 times the number of years, and that's going to be 5 years. So please, when you type this in your calculator, do this all in one step. Don't try to do this in multiple steps, because then that's when you make your mistakes. And when you do that, you end up getting your answer of $11,592.74. All right, so now let's look at what happens when we do this. It's going to be the same equation. The only difference is that n would be 2. So you have 1 plus divided by 2. Your exponent's going to be 2 times 5. Again, you could just, obviously, 2 times 5 is 10, but I didn't want you to wonder where I came up with the 10, so that's why I wrote this down as 2 times 5. But when you go to type this down in your calculator, you can just do it as an exponent of 10. And when you do that on your calculator, you get an amount this time of $11,605.41. Okay, now let's look at what this would be quarterly. So we would have $10,000 again, 1 plus 0.03. Our number of times it compounded now, if it's going to be quarterly, n would be 4. Then we'd have 4 times 5 as your exponent, which we know would also be 20. So go ahead, when you would do this on your calculator, you get $11,611.84. All right, so we're going to do this one last time. This time we're going to do it if it's compounded monthly. So if it's compounded monthly, we would take $10,000 times 1 plus 0.03 divided by 12. Our exponent would be 12 times 5, or 60. Again, you just type all that in your calculator. And when you do that, you would get, this time you'd get $11,616.17. So as we look down the row here, one thing to recognize is you would think that if compared to being compounded once a year versus monthly, you'd think that means that there would be a huge difference in our total amount. Well, here we have $11,616 if it was compounded monthly versus $11,592. So just a difference of about just about $20 there. So not a huge difference, but so it's again important to make sure that your answer makes sense in the context of the problem. If you got huge numbers there, I would go back to your percent. You made a mistake there. All right, let's look at number 2. It says Laura invests $7,200 in an account that pays 2.7% interest compounded quarterly. How much will be in her account after 12 years? So this time we're just doing this one time. So again, let's just make sure that you remember that the rate would be 0.027, and it's compounded quarterly, so that means n would equal 4. So our formula would be p times 1 plus r over n. Then our exponent's going to be n times t. So we just plug that information in. So we would have 7,200 times 1 plus our rate, which is 0.027, divided by the number of times it's compounded, which is quarterly, so n would equal 4. Then our exponent's going to be 4 times 12. And again, when you go to type this in on your calculator, You don't have to do 4 times 12. You can just type in 48 as your exponent just to make it a little easier for yourself. And when you do that, you get an answer of $9,944.23. All right, let's look at number 3. Nate invests $5,500 in an account that earns 2.4% interest compounded continuously. All right, got to read these carefully. What is the value of the account after 8 years? So remember when we see that phrase, compound continuously, that means we use our PERT formula. And our rate, again, is a 2.4% as a decimal, will be 0.024. And so our principal is $5,500 and our time is 8 years. So for your equation here, we would take the 5,500 times E, and then your exponent's going to be 0.024, your rate, times your time, which is 8. And this, again, you just type this in your calculator all at once. When you do that, you're going to get an answer of $6,664.19. All right, let's look at number 4. So number 4, it says Patty invests $6,300 in an account that earns 1.7% interest compounded continuously. Okay, again, we see that phrase. What is the value of the account after 20 years? So for this one, the rate would be 0.017. The principal amount would be $6,300, and the time would be 20 years. Again, since it says compounding continuously, remember that means we use the PERT formula, just like the previous one. So we would have 6,300, oops, we don't need the parentheses there, times E, there we go, and then our exponent's going to be 0.017 times our time, which is 20. So again, we just type all that in your calculator. And when you do that, you get $851.17. Fix that 8. There we go. $8,851.17 would be your answer for number 4. So that brings us to the end of that section. So hopefully that answers the questions that you had on those.